Good morning, students. Myself, Vijay Shankar from ECE Department, Civil Engineering College. Today, we are going to discuss about the oblique incidence at a plane of conducting boundary and oblique incidence at a plane of dielectric boundary. In the last classes, we discussed about the normal incidence at a plane of conducting boundary and normal incidence at a plane of dielectric boundary. In that two cases, we derive the expressions of reflection coefficient and the transmission coefficient. Okay. Now, so normal incidence means that there is no any angle when we apply the incident and the reflection and the transmission. Now, when the oblique incidence at a plane of conducting boundary, so actually there is two types of oblique incidence in that the horizontal polarization and the vertical polarization. Horizontal polarization and vertical polarization. Okay. First one is a horizontal polarization. Let's see. So this is a horizontal polarization. So what is a horizontal and what is a vertical polarization? Means a plane of wave is incident obliquely at the interface between the perfect dielectric and the perfect conductor. There is a boundary line is here. And the dark shade is representing the perfect conductor, and in the left hand side is a perfect dielectric. When it is called as a horizontal and when we call it as a vertical polarization, means that the electric field vector perpendicular to the plane of incidence. Electric field means E bar. Electric field E bar is perpendicular to the plane of incidence. Perpendicular to the plane of incidence. Incidence is here. There is a E bar is there, EI bar. Let us take it as a incidence means EI bar. The electric field vector perpendicular to the plane of incidence, or otherwise we can also say that the electric field vector is aligned parallel to the boundary of the surface. This is an incident beam. For this incident beam, the electric field is perpendicular, exactly. Perpendicularly means, you know, is an incident line perpendicular of E bar. Electric field is which is perpendicular to the incident beam. Or otherwise, this is an incident beam, or otherwise it's a parallel to that of the boundary. Here the boundary line is there in between of a dielectric and the conductor. Is E bar. E bar is aligned parallel to the surface. The electric field vector is aligned parallel to the boundary surface. This is called horizontal polarization. Horizontal polarization. See, it is a X direction. X is a positive direction. The wave is propagated in the Z direction. Wave is propagated in the Z direction. The another way is there. It's a mutually perpendicular to each other. See, the direction is towards our eyesight. Got it, my dear students? Actually, we are drawing the X, Z, and let us take this a Y. Y means this direction is towards to our eyes. Got it? So the E bar is exactly the perpendicular to the incident beam. E bar is perpendicular to the plane of incidence, or otherwise the E bar is parallel to that of the boundary. Okay. Means what is the H now? When the E and the H is in the parallel, means here the EI is perpendicular, means H is parallel to that of this one and perpendicular to the boundary condition. Okay, my dear students. So horizontal polarization means It is also called as a perpendicular polarization also, or e-polarization. See, consider the plane of wave is incident obliquely at the interface between the perfect dielectric and the perfect conductor with the electric field EI bar perpendicular to the plane of incidence. Perpendicular to the plane of incidence, or it is aligned parallel to that of the boundary. So as the E bar is perpendicular to the plane of incidence, this type of polarization is also called as perpendicular polarization or E polarization, because E is perpendicular to the incident of B. Got it, my dear students? What is the horizontal polarization? Why we are calling that is a perpendicular polarization, and why we are also called as E polarization? That electric field is perpendicular to the plane of incidence, so it is also called as a perpendicular polarization for the incidence plane of to the plane of incidence, to the plane of incidence with an angle of theta I here, and there is a reflection is there, the theta R. Normal incidence means there is no any angle between the boundary and the surface. Between the surface here, the dielectric and dielectric, a plane of dielectric and dielectric, and the dielectric and conductor. Okay, but now the oblique incidence means there is with an angle of theta I, and the reflection is angle with the theta R, and transmission with an angle of theta T. Okay. In the previous class, we already know there is no any transmission in the conductor. Only the reflection is there. Okay. So that is there is no any transmission here in the perfect conductor because of the conductivity is a more, intrinsic impedance is a 0. There is no any transmission coefficient. Fully it is a reflected. Got it, my dear students? So horizontal polarization is also called as a perpendicular polarization, also called as a e-polarization. Vertical polarization means is a parallel polarization, and the magnetic field is aligned parallel to the boundary of the surface. In other words, the magnetic field vector is perpendicular to the plane of incidence. Here the E is perpendicular to the plane of incidence. Vertical polarization means H is perpendicular to the plane of the incidence. Then it is called as a parallel polarization, or it is a H polarization. We are always comparing with that of the boundary conditions. Okay. So let us see how we can derive these expressions, reflection and the transmission coefficient. If there is no any transmission between a dielectric and conductor, only we have the reflection coefficient only. Okay. The unit vector in the direction of incidence wave is ANI bar. See, in this direction, ANI bar is there, and ANR bar, R is a reflection, I is the incidence. There is no ANT, because in the medium 2, we consider the perfect conductor. Perfect conductor, there is no any transmission. See, ANI bar. Okay. The unit vector in the direction of incident wave is ANI bar. Let theta I be the angle of incidence. Theta I be the angle of incidence. See, in this diagram, observe here, the theta I is there. EI is perpendicular to the top of the incidence ANI, incident beam. Let's draw a line on the z-axis from EI point. Assume this is a right angle triangle. The right angle triangle here. There is an EI is there, EI bar. EI bar is started here, and theta I means opposite side, that is a sine theta I. Sine theta I. adjacent side is a cos theta I. Okay, and the boundary line, the boundary surface line is like here, is towards the x-axis, and the wave is propagated to the z-axis. Okay, the wave is propagated towards the z-axis. This is z-axis, my friends. Okay, so we start at the EI bar, take the directions also, the direction here, and traveling in this direction, and ends at the boundary surface here. So the direction shows towards the x-axis here. So ANI bar is there. Let us take the ANI bar, this right angle triangle. To find out the ANI bar is equal to listen carefully, my dear students. ANI bar is equal to. So we started here and travel in this direction AX bar. So because it is X is in the positive direction, so it is multiplied with the sine theta I. So sine theta I into AX bar. So we start here and travel in this direction. Sine theta I is multiplied with the AX bar plus ANI, the hypotenuse, and the side plus side we have to write. ANI bar is equal to sine theta I into AX bar because it is in the X direction, and cos theta I into Z direction. So plus cos theta I into AZ bar. Got it, my dear students? ANI bar is equal to draw a line from here, and sine theta is opposite side of the theta I, and adjacent side is the cos theta I. So we start from the incident wherever we have to incident the beam obliquely with an angle of theta I, and that sine theta I is multiplied with the direction of AX bar. It is along the X direction. Cos theta I is along the Z direction. ANI bar is equal to, we got the sine theta I into AX bar plus cos theta I into AZ bar. Similarly, you can try the another equation for the draw a line like this. Now you can take a boundary line here, that is the X direction, and a right angle triangle. Now consider the right angle triangle like this. A line here and the hypotenuse, and draw the line. So consider this is a right angle triangle with an angle of theta. Angle of theta. So the reflection starts from here itself. So travel in the opposite direction of the Z. So the direction is a Z here. Z direction towards the positive. Now it is opposite direction traveling. So theta R is there. So theta R means adjacent side is the cos theta R. And the theta R opposite side is the sine theta R. Sine theta R. At this place we have ER bar, and the direction ANR bar. We need the ANR bar value. So apply the whatever we did here. ANR bar is equal to, according to this right angle triangle, hypotenuse is there, side plus side. We start from here and travel up to the ER bar. Okay. Now consider here, if this is towards opposite direction of the AZ, means cos theta R is multiplied with the cos theta R, and the direction shows here the minus AZ bar. Minus AZ bar. Okay, and the sine theta R. So this is a sine theta R. Sine theta R is traveling in the positive x direction only. So plus sine theta R into AX bar. Sine theta R into AX bar. Got it, my dear students? From these two right angle triangles, from the first right angle triangle, we find out the ANI bar. Okay. As ANI bar is equal to, we started here, and the sine theta is in the x direction, sine theta into AX bar, cos theta into AZ bar. Both are in the positive direction only, but in the reflection, ANR bar is equal to cos theta R is in the opposite direction of the Z. So cos theta R into minus AZ bar plus sine theta R into AXO, because it is in the X direction. Got it, my student? The two right angle triangles we find here. Then after, we can substitute this ANI bar and the ANR bar values to find EI and ER corresponding to the HI and the HR also. Got it? How we got the equations from this diagram? Okay. Draw a line perpendicular from EI. Here the EI is perpendicular to the line of incidence, the plane of incidence, simply saying. The electric field E bar, the electric field vector perpendicular to the plane of incidence, is called, this type of polarization is also called as a perpendicular polarization, because it is an electric field is perpendicular to the plane of incidence. We can also call it as an E-polarization. Understood? Now let us see the other equations. I hope you can understood how we got the ANI and the ANR bar. The next, go for the other equations. So ANI is equal to sine theta into AX bar, cos theta into AZ bar. So substituting the EI bar is equal to, EI bar is equal to, in this EI bar, EI is a magnitude, and the phase is e power minus j beta 1. Why I am taking the j beta 1? Alpha is equal to 0, the gamma into the direction what we have here, ANI dot R bar. Okay, ANI bar dot R bar. And EI is in the x direction. We'll get here the AY bar. In the power itself, my students, it is AY bar. So EI bar is equal to x direction, and the z direction is the remaining what we have here in the y direction, the E. That is equal to EI into e power minus j beta 1, because the gamma is equal to alpha plus I beta, e power minus gamma into z direction actually. That is a z, we have ANI dot R bar into AY bar. The gamma alpha is equal to 0 means it becomes of I into beta 1. Okay. Now ANI bar, we got the sine theta I into, listen carefully, my dear students, so sine theta I into AX bar plus cos theta I into, we got this from the right angle triangle, AZ bar dot R bar. R bar means it is a X into AX bar, X into AX bar. Cartesian coordinate system, X into R, Y into AY bar plus Z into AZ bar. Okay. Now when I am multiplying, not multiplying, the dot, apply the dot product of a sine theta I into AX. AX dot AX only will get the value, and AX with AY is a 0, and AX with AZ, the dot product is a 0. Different dot product value is a 0, itself is a 1. Okay, then we'll get sine theta into AX bar into X in dot with the X into AX bar means X sine theta I, X sine theta I plus X sine theta I and cos theta into AZ bar. So AZ bar dot AX bar is a 0, AZ bar dot AY bar is a 0, AZ bar dot AZ bar is a 1. So that is a Z into cos theta I, Z into cos theta I, will multiply with the AY bar in the power itself. Okay. So EI is equal to what we got here, the X into sine theta I plus Z into cos theta I, X into cos theta I plus Z into cos theta I. Got it, my dear students? Directly, without knowing the ANI bar dot R bar, we can get this expression by taking the another right angle triangle. From the figure, another right angle triangle, directly we'll get X into sine theta I plus Z into cos theta I also. Or otherwise, as a logic from the diagram, ANI bar you can find and you can substitute that using the concept of the direction cosines for equiphase surfaces. The equation of the incident wave can be written as ANI bar dot R bar, so X into sine theta I here, sine theta into AX bar plus cos theta into AZ bar dot X into AX plus Y into AY bar plus Z into AZ bar into AY bar. And the dot product, after applying the dot product of these two functions, X sine theta I, Z into cos theta into AY bar. Okay, we got the EI bar is equal to, EI bar is equal to. Okay. Then magnetic field, the equation of incident the magnetic field is the formula for to find the magnetic field after finding the electric field, HI is equal to. So actually it is the ratio between of electric field by the magnetic field is nothing but the intrinsic impedance. Eta is equal to EM plus by HM plus. EM plus is a magnitude and HM plus is a magnitude. I need the HM is equal to EI by EM plus by eta. Is a formula we have. H is the EM by the eta. Since it is in the medium one, I need the vector of incident magnetic field, HI bar is equal to, the denominator is a eta 1, since it is in the medium one, and related with the EI is ANI bar cross EI bar, ANI bar cross ER bar. Okay, you have to find out the cross product of ANI bar cross EI bar. Understood, my students? So now I can substitute this EI bar, HI bar is equal to HI bar is equal to EI by the eta 1, EI by the eta 1, EI is the magnitude, EI into e power minus j beta 1 x sine theta I plus z cos theta I ay bar, and this is a cross product with ANI bar. Okay, here directly I represent here itself only cross ANI bar whole divided by eta 1. Nothing but the HI bar is equal, as I substitute in this equation, ANI bar cross the total function what we have, the EI bar is equal to. So how we can find this ANI bar cross the function? The EI is a constant value. The exponential value also you can keep here. And ANI bar cross with the AY bar. What is the ANI bar is a sine theta I AX bar plus cos theta I AZ bar. Here the AY bar is a cross product of AY bar. Okay, is a ANI cross AY. So why I did write this a cross here itself means before the cross is a change of the signs also. ANI cross AY bar. The remaining total function what we have here is a constant. It's totally constant, and you can apply the cross product with the AY bar. So what is a cross product? We know X and Y, if it is an order X, Y, Z, X and Y, you'll get the positive Z on. Y and Z, you'll get the positive X. And Z and X, you'll get the positive Y. So here it is in the order only the AX cross AY. So sine theta I into AX and cross with the AY means we'll get the AZ bar. Okay, and Z and Y, the cos theta I into AX AZ cross AY. AZ cross AY means it is in the reverse direction. So reverse direction means plus cos theta I into AZ cross AY is a minus AX bar. Minus AX bar. Got it, my students? So you can substitute this equation here. The totally is a constant EI by the eta 1 here, e power minus j beta 1 multiplying with x sine theta I plus z cos theta I is a constant. Now you apply the ANI cross AY bar means what is the expression here? Cos theta I is a whole multiply. Don't write the multiply for the power. This total function is multiplied. We get the sine theta I into AZ bar, and get the cos theta I minus we got minus cos theta I into AX bar. So this is a total function of the magnitude HI bar is equal. Okay. Got it, my students? The sine theta into AX bar, AZ bar, and cos theta into minus. And this function also will get from the right diagonal itself. What we got here? Sine theta into AZ bar and cos theta into minus AX bar. Okay. You see here? cos theta into AX bar minus AX bar and sin theta into AZ bar. The HI is equal to. Okay, my dear students. So from the diagram, how we can find that equation? Let us draw a perpendicular line here, and similarly the hypotenuse and one right angle triangle here itself. Okay, my dear students. What we got the expression? The expression we got cos theta I into minus AZ bar, not the minus AZ bar, AX bar plus sin theta I into okay, AZ bar, sin theta into AZ bar. See, here we got the one right angle triangle. Let us take here the theta I is there, the theta I. Opposite side is the sin theta I. Opposite side is sin theta I. And adjacent side is a cos theta I. So EI is started here. So the direction is downwards and direction is towards a positive. X direction. See, there is a X direction is a positive, X direction is towards here, and the downwards means that is a minus EX. Is a positive Z direction towards the positive only. So from this right angle triangle, we can write as cos theta I into minus AX bar. Why it is a minus AX bar? It is opposite to the direction of the X, it's a positive and then the negative. And it is a travel in the negative direction. Sin theta I is travel in the positive Z direction. So sin theta into AZ bar. So without doing that, it is a cross product directly by using the right angle triangle here. Already we find the ANI bar from this right angle triangle. What we have here. Okay, this is the started point and travel in this X direction positive and Z direction. Now it is travel in the negative X direction and the another one is a positive Z direction. Okay, like that we can find out the direct equation and multiply the coefficient what we have, the e power minus j beta 1 into something. Okay. Now we got the two equations, electric field and the magnetic field of ENI, the normal, not the normal, incidence field. Now we can find out the reflection for reflected wave. The unit vector in the direction of the reflected wave is given by ANR. I already told the ANR is equal to, from this right angle triangle, from started here, opposite to the Z direction and the positive X direction. So cos theta R into minus AZ bar, sin theta R into AX bar. Okay. Sin theta R into AX bar plus cos theta R into minus AZ bar. Minus, okay, where the theta R is an angle of reflection. The theta R is an angle of reflection. The electric field of the reflected wave is, what is the electric field? Again, you can same the equation. Previously, we take the EI, now it is a ER bar is equal to, the magnitude is ER and e power minus j beta 1 into ANR bar dot R bar into AY only, because the wave is propagated in the X Z direction and the X is already there. X is the boundary surface, and now that for the boundary line, the ER is a parallel, or the incident beam, the E electric field is perpendicular. Okay, AY bar. So ER bar is equal to ER into e power minus j beta 1 into ANR dot R bar. Already we got that ANR bar dot R bar is ER is equal to, ER bar is equal to, sorry, ER into e power minus j beta 1 into R bar Already we got the AX is the AX bar. Applying the dot product with the R, you get the X into sine theta R. X into sine theta R. Got it? And cos theta R is the AZ bar. AZ bar only the dot product is a 1. So minus Z into cos theta R. Cos theta R into AY bar. Okay. After the dot product, ER into e power minus j beta 1, X into sine theta R minus Z into cos theta R into AY bar. Okay. Similarly, you can find out the magnetic field also. Magnetic field. Here we can take that is a magnetic field is HR bar is equal to HR bar is equal to HR bar is equal to ER bar or ANR bar cross ER bar divided with the eta 1 only. Okay. Now, in this ER bar, the ER is a constant and e power minus j beta 1 X sine theta minus Z cos theta AY bar is there and eta 1 also. And this AY bar, apply the cross product with ANR bar. ANR bar is equal to, we got a sine theta into AX bar minus cos theta into AZ bar is cross product with the AY. That is equal to sine theta R. AX and AY is in order. We'll get the sine theta R into AZ bar only. Already minus here. Z and Y. Z and Y is opposite direction. Opposite direction means cos theta R into AX bar minus AX bar because Z and Y is in the opposite. X, Y, Z. Cross product of XY is a AZ bar, YZ is a AX, and ZX is a AY. But Z and Y is a minus VR. So ANR bar is equal to, now I can simplify the ANR bar is equal to, we got the sine theta R into AZ bar plus cos theta R into, sorry, here the cos theta R is there, cos theta R into AX bar. Already the minus is the minus into minus is a plus. So multiply this total function with the sine theta R into, so sine theta R into AZ bar cross, not the cross, plus cos theta R into AX bar. Nothing but the HR bar is equal to the total function. Without applying the cross product here, from the diagram itself, we can write this as sine theta R AZ bar plus cos theta R into AX bar. From the diagram itself, see here. And see, there is a diagram what we are previously to find the HI bar. I draw a perpendicular line and apply, take that as a rectangle triangle here itself. Now here also you can take to get the sine theta R into AZ bar plus cos theta R into AX. Adjacent side. The theta R is there. Let us take theta r. I think towards the H we have to draw the diagram. Okay. Let us take here the theta r is angle. Opposite side is a sine theta r. And adjacent side is a cos theta r. See, the x direction is a positive only. Positive direction, and here also the positive direction. So sine theta r into az bar and cos theta r into ax bar. Okay. Here also we draw a right angle triangle with the h bar. Consider the theta I here. Adjacent side is a cos theta r and opposite side is a cos theta I, sin theta I, sorry. By using these two right angle triangles, you can directly get without doing the cross product of a and r cross with the ay. Okay. Then finally we got the two equations, hi and ei, as ei bar and hi bar from the incidence, and for the reflection hr bar and the er bar also we got the equations. Got it, my dear students? Now combine the equations because it is in the medium one. In the medium one, both the incident and the reflection. In the medium one, both the reflection and the incidence, E1 bar is equal to the combination of EI bar plus ER bar. Both are in the medium one. EI bar plus ER bar. So what is the EI and the ER is equal to? EI bar is equal to, we got the expression as EI into e power minus j beta 1 into whatever the expression equation we got, sin theta I into, let us see that equation. What we got, EI is equal to x into sin theta I. Sin theta I into x plus z into cos theta I. Z into cos theta I ay bar. And similarly the hi bar is equal, not the hi, ER bar is equal. ER bar is equal to ER into magnitude e power minus j beta 1. You see what is the equation we got, ER is equal to x sin theta r minus z cos theta r into ay bar. Now you can combine the two functions to get the E1 bar is equal to EI plus ER function.